one very important aspect of programming is recursive questions. And recursive question can only be done by using a method. A recursive definition is used to define the elements in the series in terms of other elements in the series, usually the previous ones. For example, factorial. Factorial can be considered as 1 times 2 times 3, for example, times all the way times n. This is a series of elements combined together, multiplied together. So as for n equals to 1, then factorial n equals to 1. If any n that is greater than 1, factorial n equals to n times factorial n minus 1, which means we define this element, factorial n, by using the factorial, the other elements in the series, which is the previous one. Similarly, for Fibonacci series, if the n is equals to 1 or 2, then Fibonacci n equals to 1. If n greater than 2, then Fibonacci n equals to the n minus 1 Fibonacci element plus the n minus 2 Fibonacci element. As you can see, this is method, and this method can only be achieved by calling itself. You want to get a factorial n, you need to get factorial n minus 1. This is what we call recursive. So a method can call itself, thus forming a recursive series. Recursive definition can make certain definitions simple. Thus it's very useful, especially in handling time series. So you can see, like for Fibonacci series, it's much simple and elegant to define this way instead of if you want to write it down in other way. So let's try to create a factorial class by using recursive method. And in the factorial class, again, Java doc. Let me copy the factorial definition. And factorial equals 2. And here is the. Now let's add public static void main. And we need to add string array args. Now, in order to calculate factorial, we will need to define a method so that it can call itself. This is done by creating public static integer factorial integer int. I'm sorry, I've been switching between different languages, and the int and integer always makes me confusing n. So now you can see factorial. There's an error because I haven't returned anything, I believe. I believe that's because I haven't returned anything, yeah. So if I want to do a system.out.print line factorial 10, I need to do return. Now remember we had that conditional operator. This is where it can be used most often. So if n equals to 1, right? Of course, you need to put the equals to equals here. Then you are returning 1. Otherwise, you will return a factorial n minus 1. You do not need to write a for loop. You do not need to write a long definition. This is one single code that you can use. So let's see how it works. And I think I get something wrong here. if n equals to 1 factorial. Oh, I forgot n times. So let's see how it works for 100. So for 10, and you get this. And I'm actually not sure whether this is the factorial for 10, but I know what it is. Is it for 4? It's 24, yeah. So this is correct. Now let's take a look at a further advanced example, which we will also, because for factorial, it's one series. You honestly, if you just do it this way, 1 times 2 times 3 using the 4, it's not going to be much different. But for Fibonacci series is pretty much a good definition, a good usage of recursive definition. Because if you want to do because basically it's like a n, start with n, then you branch into n minus 1 minus 2, and n minus 1 itself is a branching of n minus 2 and minus 3 all the way down. That means it's very hard to write a linear solution for it. And recursive solution will be much easier. So let's copy. Let me copy this. And I'm going to create a class called Fibonacci. Do I have one C or two C's? Yeah, two C's. I know I was wrong. So Java doc, as always. And then public static void main string array args. And we will create a method called Fibonacci. Let's say 8. I want to get the 8th number of Fibonacci. Now let's create a public static integer Fibonacci, and I'm writing the whole word Fibonacci here. And in reality, you will see a lot of people also just write fib, which works here too. Fib int n. And now let's still use this conditional operator, n less than 2, less than or equals 2, which means it will be either 1 or 2, right? Then return 1. Otherwise, it will be fib n minus 1 plus fib n minus 2. Now, I'm not adding boundary check for it, which means I'm not checking whether this is greater than 0. It has to be, but for this particular method, let's just do it this way, and let me run. So the 8th is supposed to be 21. If you actually check the Fibonacci series, it should be 1, 1, then 2, 3, 5, 8. So 2 equals to 1 plus 1, 3 equals to 1 plus 2, 5 equals to 2 plus 3, and 13, and 21. So this is the 8th. 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th number of fib. Now, what if I want to add a check? Then I need to also put something like if n greater than less than 0, what will be the return value? And here we are lucky because usually in the mathematical expression, if n less than 0, we usually set Fibonacci n also equals to 1. So here, anything less than 2 should return 1. So this is how you define a Fibonacci series. Now you may notice that in order to calculate fib n, we're calculating fib n minus 2. And in order to end the fib n minus 1, now while I'm calculating n minus 1, I have to calculate fib n minus 2 again, which is a kind of waste. We will take care of this performance issue after we learn the array definition.